So, Ayubowan and good evening, everyone. So, it's a pleasure to meet you at our online webinar on the art of data science with Microsoft Azure. So, myself, I'm Anjana Dodampe. I'm a beta Microsoft Learn student ambassador. Alongside with me, I have Sahan and Thathsarana.
Hello, I am Sahan Dissanayaka. I am also a beta Microsoft Learn student ambassador. I will be teaching you today about modeling the data for machine learning at the segment 2.
Hello everyone. So I'm Thathsarana Weerakoon, also a beta MLSA. I'll be covering the segment 3, data science with Azure. So let's start with segment 1, art of data science with Anjana.
So guys, now let's start our first segment for the day, the art of data science. So throughout this segment, I will be walking through the importance of data, what is data science, the buzz in AI, ML and data science, and need for data science, and data science workflow, and the job roles, and how data science is shaping our world, and data science methodology, and what you need as a beginner, and where to begin. So to start the proceedings, let's explore the importance of data. So when we heard the term data, we can identify various types of things such as quantities, information, graphs, measurements, observation, facts, and numbers. So this data can be defined as a representation of facts, concepts, or instructions in a formalized manner, so which can be used for the communication. So in the modern context, we have more data available than ever. So we can identify vast quantity of data which are available from various kinds of sources. So we can identify data sources such as log files, email, social media, sales data, patient information files, and sport performance data, sensor data, security cameras, and many more. Day by day, we are generating trillions of data. So today we have the computing power needed to make useful analysis and reveal new knowledge from the data we gather day by day. So as there is a modern saying that the data is the new oil. So data is absolutely the new oil of the 21st century. So in order to get insight from this data, so we need a bit of science to extract knowledge hidden in this data. So that's where we meet data science. So as you can remember, in the registration form, I have asked a required field on asking your thought on data science. So I saw so many interesting opinions there. So I picked a few. So some said it's the future. So absolutely, data science is the future. The future we are witnessing today, as well as future can be predicted by data science. So actually data are the summaries of thousands of stories. So actually when it comes to data science, it is a kind of handling data in an effective way. So we are living in a world where we mainly run through technology. So it's where the science of data come to our rescue. So process of collecting data, analyzes data, interpret data, and present data. So it is also a closer opinion to the data science actual definition. So when it comes to our actual definition, what is data science? So data science is a study of large quantities of data which can reveal insight that help organization to make strategic choices. So in that sense, data science is just like the art of uncovering insight and trends that are hidden behind data. So when it comes to data science, this data science immensely helps the organization. It helps to understand the organization, their surroundings and the environment, the domain they are working on, and it allows them to analyze existing issues in their system, as well as it helps to reveal previously hidden opportunities. So in simply, the data science, or as well as we can mention it as data-driven science. So it is actually, in simple terms, it is asking the right question and exploring the data, and then the modeling the data using various algorithms, which supports with the aid of machine learning techniques. And then finally, we communicate and visualize the desired results we obtain through these models. So in the current computing domain, we normally come across various buzzwords. So this artificial intelligence, machine learning, and data science are the hot picks. So when we take artificial intelligence, it is the ability of a machine to mimic human behavior. That means AI means a program that can sense, reason, act, and adapt. So when we take machine learning is using various techniques and algorithms that we use to make models from whom we can improve the performance as they are exposed to much data over time to time. So when we take deep learning, it is a multi-layered neural networks which learn from vast amount of data we feed. So when it comes to data science, as I mentioned in the previous slide, it is the area of study extracting knowledge from large piles of data. So when we consider all these terms, so we can say that artificial intelligence is a superset. So under that superset of artificial intelligence, we have the subset machine learning, and under the machine learning, we have the subset deep learning. So this data science, where does it fit? So that might be a bit of a question for you as well. So actually, data science is not a subset, but actually it is an intersection of all these three domains: artificial intelligence, machine learning, and deep learning. It is not merely a subset of AI, but an intersection. That's how data science intervenes all these domains. So when it comes to the need for data science, we basically need this data science to make better decisions. So when we have certain set of data, we need to make conclusive predictions based on those data. So we can take business decisions using machine learning models. So that's where data science intervenes for the better decision making. As well as it helps to predict analysis. That means we can guess what will happen next. So identifying a pattern of data we provide, we can train a model to detect what will happen next in that procedure. As well as we need data science for pattern discovery. So we can identify various patterns in data sets, and we can uncover the relationships between them, and we can predict and we can identify the patterns in them. So when we take the data science workflow in simply, so this diagram shows the data science workflow in a more clear and precise manner. So for the data science, we basically take a current real world problem we are facing. So we first get the understanding and domain knowledge on the problem, then we gather data related to that problem, and then those gathered data is processed and analyzed to make a model which can predict the outcome we expect. So after processing and analyzing all those data, we get a meaningful data set which we will be using to feed a model. So we add this model to get useful insight. So this is basically the simple workflow in a data science scenario. So when it comes to job roles in data science, so we mainly can identify several data professional job roles that are prominent in the field of data science. So we have data engineer, data analyst, data scientist, and business analyst and business intelligence analyst. So apart from that, we have AI engineer and machine learning engineer as well. But in this case, these job roles are the roles that interact mainly closely with data. So that's why we specifically mention these job roles as data professionals. So when it comes to data engineering role, the main responsibilities of a data engineer is extracting and integrating and organizing data from various sources. And the data engineers clean and transform and prepare all this data which needed for ingestion. And the data engineer and design, store and manage data in data repositories such as data lakes and data warehouse. And to become a data engineer, you should possess a good programming knowledge, and you should have a sound knowledge on systems and technology architectures, and you should have in-depth understanding on relational databases and non-relational databases. So when it comes to data analyst, the main responsibility of data analyst is to inspect and clean data for deriving insight. And the data analyst should identify correlations, and he should find patterns and apply statistical methods to analyze and mine all this data. And data analysts should be able to visualize data and interpret and present their findings to the stakeholders. So when it comes to the skills required by your data analyst, the data analyst should possess a good knowledge on spreadsheets and writing queries and using statistical tools to create charts and dashboards. That means mainly focus on the visualization tool. And also data analysts should possess programming skills and strong analytical and storytelling skills. So when it comes to data scientists, the data scientist should analyze data for actionable insight. And the data scientist is the person who is in charge of creating all these predictive models using machine learning and deep learning. So as a data scientist, you should possess knowledge of mathematics and statistics and good understanding on programming languages and databases and building data models, and should have a domain knowledge as well. So when it comes to business analyst, so business analyst is a job role which leverage the work of data analyst and data scientist. So business analyst mainly focus on the market influences that shape the business, and the business analyst should organize and monitor data on different business functions and explore data and extract insights and actionable strides to improve business performance. So now let's see how data science is helping the world, and it is making a huge impact in the current world. So as you know, the climate change is the biggest threat in a major threat that our generation has to face and already facing. So according to the World Economic Forum, we can use data to have a major role in helping to get to know about the impacts of climate change. So the data from multiple satellites and mixed with insights from organizations and analyzing data coming from deforestation and other similar insights will help to get so many unresolved answers about climate change. So there are several initiatives already established. Those are based on AI and mainly data science. So in the Microsoft also we have initiatives like AI for Earth, AI for Good, and AI for Social Well-being. As well as in Microsoft we have a planetary computer That means a planetary computer is a large network of computers which includes a large number of data sets regarding the natural resources of the Earth and the animals and everything. Every topographical feature of Earth are included in this planetary computer, which can be used by the data scientists and anyone who is working on solving all these climate related issues, and the government and authorities to take action, so they can use this planetary computer. So this data science and machine learning plays a major role in tackling climate change. So we can predict the incoming disasters and the rises of sea level and the changes in the weather patterns in the coming years thanks to this data science. So when it comes to pandemic in today's time, as you all know, we are suffering from this COVID pandemic. So it is the biggest problem of the world currently we are facing. So this virus has confined everyone in their homes and the entire world is under lockdown. So the only hope of getting out of this situation is through understanding and finding hotspot and finding the way how the virus is spreading. That means virus is traveling between locations. So in order to get all these insights and understanding that only come through data analysis. So through data science capabilities, all these healthcare authorities and relevant parties can track the areas where the virus spread, and they can mitigate the damage by taking precautions much earlier. All these are done thanks to the predictions and all the data insights getting from various means of data science. So from that way, the data science is helping to mitigate the transmission and mitigate the spread of the disease. As well as data science play a major role in inventing the vaccinations and new medication for this COVID as well. So I think you all have used apps like Uber, PickMe to fulfill your various travel requirements. So you have been able to book a ride at a justified price for sure. So data science does all this homework and how crowded the route is and who is the nearest driver and the vehicle they have and the weather, and as well as these apps provide you the estimated time of arrival and the right price. So all these have brought to your hand thanks to this data science effort. So data science is immensely helping in all these revolutionary technologies that involve in transportation sector, such as autonomous vehicles, bike sharing, and personal travel assistance, and smart parking, and so many cutting-edge technologies are running today thanks to this data science aspect. So, and one more thing is the impact on logistics. So in these days, the online shopping is the easiest and safest method. I think you all have the experience of receiving your ordered packages quite quickly. So brands like Amazon and other Alibaba make use of the data science to judge which product will be demanded in which areas. So this helps them to keep the products in stock so that they can be shipped on demand. So most delivery agencies prefer to get the use of data science to estimate the traffic patterns and potential obstacles and weather patterns to decide the best route where their logistic carriers can travel. So when it comes to entertainment industry, so in there also data science plays a major role. So on the basis of your entertainment consumption, Video streaming applications guide you through the next thing to watch. I think you all have that experience when surfing YouTube and other social media as well. So the channels like Netflix use data science for their recommendation system and use to curate original content on the basis of the mass user preference. So that's how you get nice suggestions on your feed once you watch similar kind of movies and TV shows. So that's how the data science shaping works. So now let's move to the data science methodology. So under data science methodology, we can identify the data science lifecycle. I think a majority of you know the software development lifecycle. So like that, there is a data science lifecycle as well. So this data science lifecycle consists of 7 components. They are business understanding, data collection, data preparation, exploratory data analysis, modeling, model evaluation, and model deployment. So now let's explore each step one by one. So when it comes to business understanding, it is the most immediate step of this data science lifecycle. So we have to define the problem clearly and understand the requirement we have to deal with. And as a data scientist or data science professional, you have to ask required questions and gather all the required details from the stakeholders and clients. So when it comes to the next step, it is the data collection step. So in this stage, we identify various data sources and we acquire data from all these sources. They can be web servers, logs, databases, APIs, and online repositories. So we basically fetch data from these sources. So in the next step, that is data preparation step. So here we basically do data cleaning, which is also called as data wrangling or data munging. That means we remove all the inconsistent data types and misspelled attributes and missing values and duplicate values. So this stage helps us to gain a better understanding of the data, and it helps to prepare all those data for the future evaluation. So then we come to the next step. It is the most important step of this data science life cycle. It is the exploratory data analysis. So in here we define and refine data. So we pick the important selection features which we expect to use in the model development. So that's why this stage is the most significant step of this data science life cycle. So when it comes to the next step, we have the modeling. That means we develop a model. So we take the prepared data from the previous stages as the input, and we try to prepare the desired output we expect to get to tackle this problem. So we have to identify the model that fit best for our business requirement in this stage, as well as we train the models on the training datasets and testing datasets. So then comes the model evaluation stage. So here we evaluate the model by testing the accuracy and relevance, and we make sure there is a correct balance between specificity and generalizability, which main intention is to create the model unbiased. And here, based on all this evaluation, we pick the best performing model out of the models we make. So as the next step, we have the model deployment stage. So before the model is deployed, we have to make sure that we have picked the right solution. That means we have picked the right model which need to be deployed. Then we deploy this model in the desired channel and format. So that's how the data science lifecycle looks like in a simple possible way. So, but in the industry, the data science life cycle looks like this in majority of applied data science projects. So when it comes to applied data science project in the industry, so we use this data science life cycle, the team data science process, TDSP. It is an agile iterative data science methodology which is used to deliver predictive analytics solutions and intelligent applications efficiently. So this TDSP includes best practices and structures from Microsoft and other industry leaders which help toward the successful development of various data science initiatives. So this is, you can see, not like in the previous, I took the previous example for the better, to make a better clarification. So you can see how in this real world applied scenario, all these components have interrelated connection. So that's how basically the applied data science projects work. So in order to do data science or follow data science, you should have several prerequisites. So what you need to have is, the most important point is you have to be curious about this domain. So you have to be find new things and explore the surrounding world, business problems, and the domain knowledge on the technology. So you have to stay curious all the time. And you should develop a common sense. That means here we mainly deal the real world problems. So in order to deal with all those real world problems, you have to possess a good problem solving skill and a common sense to understand the business problem. As well as you should have a strong communication skills. That means here what we do is we take data and we process, and we have to present the outcomes. That means we have to present them to our stakeholders and clients. For that, you have to possess strong verbal and writing communication skills, and you should be proficient in presenting and demonstration skills as well. When it comes to data science, you should possess all these components: machine learning, mathematical modeling, statistics, computer programming, and databases. So machine learning is the backbone of data science. So this is the main, actually one of the many ways that in data science we use to find solution to a particular problem. So then comes the mathematical modeling. So this mathematical modeling skill will extremely helpful to make fast calculations, and it will helps to make predictions from what you know of your data. So you should possess a strong statistic knowledge as well. So basically statistics is the foundation to data science. That means we are dealing with piles of data, and it helps to extract knowledge and better results from the data. So you should have a good domain knowledge on statistics as well. And you should have a good knowledge on computer programming. So you specifically should master at least one programming language, preferably Python or R for data modeling, as well as you have many other languages. You have Scala and Java as well, but Python and R are widely used and they are easy to learn as well. So, and also another important fact is you have to possess a good knowledge on databases. So you should possess the discipline of querying databases, and you should possess, you should know how to handle data, and that will force you to ask better questions as a data scientist. So when it comes to learning data science, so as I mentioned, there are certain skills and tools you should know when learning about data science. So when it comes to data analysis, you should strongly possess skills such as skill in R, Python, and statistics. And for data analysis, we use Jupyter Notebooks, RStudio, MATLAB, and SAS, and RapidMiner, and Excel. So when it comes to data warehousing, you should possess the skills on ETL, extract, transform, load, and SQL, Hadoop, and Apache Spark, and Flink. And you should know how to use tools such as Talent, Informatica, AWS Redshift, so many. Once you search the web, you can find so many different kind of tools. And when it comes to data visualization, you should possess skills on R and Python libraries. And when it comes to tools, you have to master Jupyter Notebook, Tableau, and Cognos, and Raw. And when it comes to machine learning, you should possess a strong skill on linear algebra, machine learning algorithms, statistics, and you should learn frameworks and libraries such as Spark, mlib, Mahout, and Azure Machine Learning Studio, and many more on to learn about machine learning. So where to begin? So my advice is first you should start from the basic first if you are a beginner. That means you can't directly jump to machine learning without learning about the algebra, calculus, statistics. So you have to master step by step. You have to follow that path in order to have a strong base to learn machine learning. So that's why I emphasize that you should have a good foundation laid on linear algebra, calculus, and statistics. So once you have that foundation, you can build upon that. So when it comes to starting a data science project, you should start with a smaller data set, and you should master each process in the data science life cycle I explained in the previous slides. And you should learn to draw conclusions through visualization, and you should start building your model, and that stage comes only once you completed the previous stages successfully. So that's how basically you can begin your journey. So in the latter part of our today's webinar, you will learn many more resources where you can learn to kickstart your career in data science learning. So moving on. So that's it from my segment. So I would like to conclude my segment on this closing note. The future we will invent is a choice we make. So we should use all these the new technologies, trends for the betterment of world. Then only we can have a sustainable future. So I urge all of you to do the same. So use all these new trends and hot picks for the betterment of the people around you, as well as the people around all over the world. So that's it from my segment. So now I will invite Sahan Dissanayaka to start his segment on modeling data for machine learning. Thank you.
Thanks, Anjana. Give me a minute to share my screen. Hope you can see my screen. I'm Sahan Dissanayaka, as I mentioned earlier. So in my segment, in segment 2, basically I want to cover the practical aspects of what Anjana covers. And actually it is one of the best session I also heard in terms of data science and machine learning. So he covers all of the theoretical parts we should know, not only the theoretical part of statistics and machine learning, and also what are the roles and how industry manage and how the industry projects are going on in nowadays. So in my session, actually, in first place, I'm try to explore and analyze data with Python. What are the foundations? So what should we know in terms of implementation aspects of a data science model? So in that area, I will explore the data with NumPy and Pandas library and visualize those data with Matplotlib and examine the real world data with Titanic example. I hope many of you know about the Titanic dataset, which is a very popular one. And in the second part, I will be emphasizing what is the importance of data. So how data will learn and grab the knowledge, which is the wealth in data science. So what are the good and bad in missing data, examine the different kind of data and one hot vectors. In the last part, I will be covering all of these and grab into one place to make the machine learning model. And in that part, I will be covering what are the ML models. So what should you know about ML models? So how you should visualize input and outputs and how to use that model in a case study or in a practical aspect. And at last, we will be made your first ML model using Python. So let's move on. If you have any question regarding any of the explanation I have made during my session, you can use the chat and pull off your questions. So first of all, let's see how we explore and analyze data. As data scientists, the primary involves in the exploring and analyzing the data and result from the basics of a report or a learning of a machine learning model. It's all begins with data. Why am I say like that? So if you want to build a model to train, to classify, if I input an image of a number 1, 2, 3, 4, 5, as so on, you want to predict a model which number which I inputs. So first of all, we need data. So we need to feed the machine. When I input now number 1, he should predict it is 1. So what should we need? First of all, we need data of features of numbers or handwritten numbers or whatever. So that's why I said it's all begin with data. So in that all cases, the Python being an amazing programming language, it is a high-level language for data scientists and data engineers for an extensive functionalities with powerful statistical and numerical libraries. Not only statistical, as always, it is powerful with mathematical aspects as well. So in Python 2, we usually use NumPy for scientific computing and mathematical tools, and also Pandas because of its data structures and data analyzing and manipulation tools. At last, Matplotlib for data visualization. So in terms of client application, we usually use Matplotlib because as you know, we are the students of learning data science, but in terms of clients, they actually didn't know more about data science. They actually know about visual inputs and outputs. So we definitely we need to use Matplotlib in our machine learning models. So in furthermore, actually in machine learning, we need another 2 libraries that are scikit-learn to build whatever the regression or classification or decision tree, likewise to predict the data analysis part. And if you want to deploy your machine learning model to the website or whatever, a mobile phone, or you want to use that application by other people, you have to use TensorFlow or PyTorch to supply machine learning and deep learning capabilities. In this session, I will be using Jupyter Notebooks because it is the very popular way to run in basic script in web. I will be using Visual Studio Code. So those notebooks are really simple, and it is a single web page which is split into number of text sections and coding sections. So that's why I said the Python is the command of all data science armies. So one of the best choices of data scientists and data engineers is Python because of its amazing capabilities. So moving on, before I moving on to the practical sessions and the demos, I'll be using Python as my programming language, as said earlier, which is Python 3.6 and 8 version in 64-bit version, and Visual Studio Code for integrated development environment, and Jupyter Notebook to scripting my machine learning codes. And after that, I'll be using GitHub to deploy my machine learning models. So I will be sharing my GitHub link with you, so you can use it as a reference. If you are really interested about the demos, you can work with me, and if you have encountered any kind of a problem, you can ping me in the chat box. Okay, hope you find the link, and let's move on to the practicals. Okay. So at the demo 1, I will be exploring the data with NumPy and Pandas, which is really a straightforward implementation on Pandas and NumPy. I will further explain on in each of areas about data arrays and all of these in the practical aspect. And in the demo 2, I will be visualizing the data with using Matplotlib. And in demo 3, I will be examining the real world data using a real world test data set. So okay, hope you can see my Visual Studio screen. Can somebody verify it?
We can see some. Yes.
Yes, thank you. Okay, which I share the link. I think you will be all reaching the link. So in that repo, there is a section called Foundation of Python for Data Science. Inside it, there is a Jupyter notebook called Python Basics. So that is the file I am referring to. So first of all, let's see what aspect of data we can model with NumPy and using Python. So assume that there is a data collection, which is the marks of several students in a class. So if you want to print something in NumPy, it is really straightforward. Like in Python, we can use print data. So as I said earlier, in this workspace, it is really easy to follow and really easy to prototype in the codes. That's why I use Visual Code rather than going to Jupyter Notebooks. I think you might know Jupyter Notebook is a heavily intensive computational application. So sometimes it may be bulky to your computer. So, but in Visual Studio Code, it's really flexible and really simple. You only need to install the extension via the extensions tab. You can search in here like Jupyter Note, yeah, Jupyter, and it is provided by Microsoft, and you need to install it in your Visual Studio Code package, and you can use it. It's really simple. So moving on to my Jupyter Notebook script. So first of all, I will be taking a rough raw data as 50, 50, 47. Likewise, there is 15 data points. Yes, 15 data points. So if you want to print something, as I said earlier, you can print like mentioning the data as the array name. So print data will be printing the data that I will be using in my data array. So the specialty of an array and the NumPy, in a normal array in Python, we cannot use actually a lot of easy array operations, but in NumPy we can operate really easy those array operations. So if I take like this, if you want to convert normal array into NumPy array, you should use this command called np.array. So I will emphasize what is the difference between a normal array and a NumPy array. So let's assume that there is another array called data2. But in normal array manipulation, if we need to do like something like this operation, we want to subtract each of these elements from array data3 array from data2 array, like 1000 minus 100, 2000 minus 200. If we do it in normal arrays, see what will be happening. It will gain an array, but if we do it in NumPy arrays, like in here, np.array, this is the code to convert a normal array into a NumPy array. Data2 NumPy data3 np.array data3. If I print the same code in NumPy arrays, data3 minus NumPy data2. Save the code and run it. And it will be outputting the expected code, what I expected from the code, which is each of these element will be subtracted from the one array to another array. That is the difference between a normal array and a NumPy array. It is really have good features compared with the normal arrays. So moving on. Likewise, if we want to compile what is the data type of our array, we can simply use the type function in the data. So if you want to check what is the shape, so how many data is there, so how many data elements in our data set, so simply we can use the shape function. This is an attribute of the NumPy. We can see how many data elements are there. There are 22 actually, not 15, 22 elements. But if it is a two-dimensional array, it will be output 22, 2. This is output first as the rows and the columns. So there are 22 rows, 22 columns. It means it is a one-dimensional array. So there are no only one row, that's why it's not displaying anything. If you want to display one element, we can use the indexing as we normally use in other languages as well, using 0. If I input 1, I can get the 6th element of the array. So what is the another advantage of using NumPy is the statistical packages which is included in NumPy. We can directly get the mean or a median or mode of an array or NumPy array using mean, mode, and median. So it's really easy, right? So that's why we need to use when we are compiling large number of data. We are dealing with a large number of data. We need to use like these commands in order to simplify our application. So if we are moving on, these are some simple codes I have included in the in this script, so you can work on it to learn some more about NumPy. But I will, with the time consumes, I will be jumping off here and there to give you a high-level idea about pandas and NumPy. So moving on to the pandas. So if we deal with non-numerical data with NumPy, it is not supported at all with NumPy. So we need to use pandas for data manipulation and data exploration in that case. So that's why we need pandas over NumPy. So if I run this code, first of all, you need to import pandas. This is the reference, so you can use any of the name as your reference name. I use it as PD. Okay. Okay, I think I have missed some data in the student data, so let's move on. I think there are some more examples. So in that case, if the one more advantages about in data frames in pandas, it's that we can get table-like format. I know you know that when we are manipulating data with Excel kind of application, the tables are really help and easy to manage all of our data. So pandas gives that advantage for us to manage all of our data. So in the pandas, there is an attribute called log. You can see when I moving my cursor to the log, it will be displaying all the functionalities included in the log package. So simply it is using for the index purposes. As I explained here, you can use a data frame log method to retrieve data for a specific index value. And also we can use ilog to take some range of value, or if we want to get a range of columns or range of rows. For both purposes, we can use ilog. So for a single item, we can use log. Okay, these are some exercises so we can use using pandas. So let's see how we can load a data frame from a file. For that, we need to use pd.read CSV. PD means the reference that I have used in terms of pandas. So I import it again. Import pandas as PD. Okay. So this is the file I'm using. Dan, 10, 15, John, Pedro, Rosie, Ethan, Vicky, Jimmy, likewise. So I name it as DF students as my data frame name. So the data frame.head will be displaying the first 5 entries of my data set. So if I cross check with the data I have output here, yes, Dan, John, Pedro, Rosie, and Ethan. Yes, it is correct. Dan, John, Pedro, Rosie, and Ethan. Okay, so as I explained, when we are dealing with data, it is a massive case in terms of industry application as well as in university projects, as well in also in any data science project. The missing values are really a massive headache for a lot of people. So how to deal with those missing data? I will be talking more about missing values in later chapters, but in here, if we want to check is there any missing values, we can use this script df students.isNull. It will be output what are the null values in the data set. So in also, if you want to if we want to check if there is an null value in axis 1, it will be output what axis in what axis there are null values. So in here, in Bill and Ted are not including any values for the second column. So we can use any axis in here, any axis, if there is a null value, it will be displaying here. So likewise, we can handle in the missing data in pandas. Okay, so let's explore the data in a data frame. So I want to take the mean as I explained in the NumPy part. In here also, I can combine both NumPy and pandas in here. So df students.study hours means the numerical part, which is the second column of my data set. If I take that data frame, if I select the study hours and get the mean, it will be output the average of the second column. And if I take the grade column and take the mean, it will be if I execute this one, it will be output the second column average and also the both second and third column average grades. So it will be easy, right? So you can understand how level of high computational complexity decreasing by those libraries. So further moving on, I will be executing here and there. So if you can take a rough idea about the application I'm going to execute. Okay, let's see what are the another important things we need to know about pandas. Okay, in this script I will be executing bulky operation about I want to take the mean of both study hours and grade in one code. So okay, let's see. I'm loading the whole data set in here, and I am grouping them into the pass and the fail. So what is I have done in here? So in here, I'm using a condition called condition in pandas, which the number of the grade one of the student taking, it is higher than 50, higher than 60, that student will be passed, else and that student will be failed. So using that conclusion, we can do a lot of operations. So what is the conclusion in here? Using pandas, we can add more columns to our data set based on our aspect of our practical application. So in terms of the our data set, we want to take what are the who are the passing student and who are the failing student. So based on that conclusion, we can take a lot of conclusion about our data set, how many students are pass and how many students are fail likewise. So that will be all about pandas and numpys. I'll be briefing all of these things, I think, because in later chapters these similar things we need to know about to explain complex areas. So about matplotlib, as I said earlier, we need to use matplotlib heavily when we want to implement a client application, because clients usually can't understand technical terms. They usually understand the high level diagrams, and visually output diagrams will be really easy for clients to understand what happening in here, what model does likewise. So matplotlib give us the opportunity to do all of this data visualization part. So in order to import matplotlib, you need to import it as import a matplotlib in like here, import matplotlib as PLD. This is a standard term, but there are a few other ways you can import matplotlib into your code. So this is another one from matplotlib, import plyplot as PLD. this is pyplot means another package included in the library. So this is a very popular package inside the matplotlib library. So I use the same data set, the data set, and I be visualizing it as a bar graph. So we need to explicitly convert our package library and get a dot and bar dot will be creating by this command. So plt.show will be displaying. This is only creating our plot. In order to display our plot, we need to use a plt.show command. So if you want to add more information to a plot, you can use title, x label, y label, grid, likewise a legend. So all the other data you can specify as parameters to your plot, as I shown in here, plt.title, plt.xlabel, plt.ylabel, grid. If you want a grid format, you can use a grid, and if you didn't want a grid format, you can comment it. As you can see, it will be disappear the grid format of the code. Asterisk means how many rotate wise in how angle you should need to show the plot to the end users. Okay, that's I think it is far more than enough for a bar plot. Let's get into statistical analysis. So as you know, as Anjana explained in the previous chapter, data science is not a single domain. It is a multidisciplinary domain, which is some terms come machine learning, which is a computer science domain, and some explanation and derivations come from statistics, and some explanation coming from mathematics to denote the formulas and all model definitions. So in statistics, we need to more incorporate about statistical analysis in terms of data preparation. So statistics and data distribution is used in data modeling to visualize what is raw model of our data. So I have used in the previous chapters. I can see, so what is the data distribution of my data set? So how many students are taking more marks and how many students taking lower marks? So you know, this is the normal distribution curve. So as you can see, a lot of students are distributed between 40 and 60, and low students are distributed between 80 and 100, and 0 to 20. So like this curve, we call it as a normal distribution. If it is a normal, if it is not normal distribution, it will be a skewed one. So those measures we can we say it is as measures of central tendency. We can measure central tendency using the mean, median, and mode. I know that those are really simple statistical stuff. So mean is measuring the average, and median measure the middle number of the range of sample values, and mode taking how many occurrences are usually occurred in our sample data set. In here, I am taking all of this data and output all the data. What is the minimum value? What is the maximum value? What is the mean? What is the median? And what is the mode? So those statistical operations can easily manipulate using pandas and NumPy. So using data manipulation, we can use data visualization to display those data using a graph, which is really easy to understand any of us what is happening in here. So that is the combination of NumPy, pandas, and matplotlib in terms of statistics. I hope you will be getting what I'm going to say. Also, you can output a box plot as we use bar graph in matplotlib. You need to define a plt.box plot to take the to show, I think, great. Okay, I think CF students. If we take study hours, I think there is some small error in this part. I think it should show the box plot about all the data. What is the minimum value, what is the maximum value, and what is the mean and median likewise. So this is a colorful explanation about the data distribution of the same data set I have using previously. Okay, let's see. Okay, this is the curve of data density, which emphasize how the data distributed over the normal distribution curve. I previously used a bar graph, which is also named as a histogram. So this is a normal distribution curve. So also we can tell it as a normal distribution curve. So in order to create such a data density curve, you only need to use pandas and matplotlib and only the xav line command to curve it, the mean, median, and mode to emphasize the data density of a data set. So I think that will be enough for measuring the central tendency. So let's move on to the variance. You know, all these terms of median, mode, and mean are the measure of tendency, but we know rather than measuring the central tendency, there are a lot more attributes and characteristics we should know, and we should make sure that what our data is behavioring. So in that aspect, we need to know about measure of variances. So to measure the variances, we need some of the measures in statistics, range, variance, and standard deviation. So range is simply taking the difference between minimum value and maximum value. Variance is the average of square difference of the mean. And standard deviation gives a square root of variance. All of these measures can be easily computed by using pandas. To calculate the range, we can use pandas.max command, max function, and for compute the minimum. And variance, we can use var. For standard deviation, we can use std function. So also okay, I think this will be a good thing when you are executing some script in Visual Studio Code. If you get such incidences as this Python library is not defined in your workspace. In such incidences, you can use your Python see to open my terminal. Okay. Usually you need to import all of you need to install all of your Python libraries to your Visual Studio Code in order to execute those libraries. But in here I'm not import SciPy in my machine, so it will be gaining an array. So I'll installing SciPy. Meanwhile, if you have any questions, you can ask from now. I don't see any questions in the chat box. I hope there will be no question.
Sahan, we are experiencing a technical difficulty in enabling the chat.
Okay.
So at the end of the segment, we'll be giving you a chance to unmute your microphones and raise your question.
Cool.
Please accept
That will be
apologies for the inconvenience.
So let's see. Will be the case. Okay. Okay. Sorry for that. I'm not aware of that. So being a rough idea, giving you about the statistics part, we can measure the central tendency as well as the variance using. Okay. Hope you can see my screen. I think I went offline for a moment. Okay. So that's about it. The basics of NumPy and Pandas and Matplotlib. This is a really brief explanation about those two packages. So hope you all get a rough idea about those two packages and how we deal with those packages with our datasets. So that's not it. So what is the importance of data? As Anjana explained in the last chapter, it is the new oil in the 21st century. So data represent the knowledge to learn in our model. So as I said earlier, it's all begin with data. After we collecting our data, it is really important to grab all of relevant data. So machine learning predictive powers come from as long as that it's shaped by data. So when you analyzing the data, there are few things you should need to consider about. So the one of the major aspect is your data should not be just large but representative. As an example, if I take you through an example, if you want to take corona patients in Sri Lanka, you need to take a good sample from corona patients in Sri Lanka, not just taking 1 or 2 patients from Sri Lanka. Also, it is not significant to take the first patient which is recorded in Sri Lanka. You need to take the relevant cases and what are the obvious cases reported in Sri Lanka regarding the corona patients. It will be output more significance of our data rather than displaying some data explanation about our data sets. So we should consider about our data should be representative about our sample set in our population. So it should not contain errors like missing values, null values. We should aware of that. And also there should not be missing key information like if you want to output the age distribution of corona patients in Sri Lanka, you should really need age column in your data sets. So that's why it's mentioning you should not be missing key information. So how to remedy? So how to get rid of those problems? So how to analyze and visualize missing data? So as I explained earlier, the representative means if you're taking a population, the population is corona patient, your sample set should be represent a good amount of your data set. That is mean by representative. As I said, data errors means sometimes it's missing data, sometimes it's avoid some important data sets, important data attributes like age, what do you call in corona patient, in what variant of the patient get infected. So likewise, you should not missing the key information and don't contain errors. So all of if we get rid of all of these missing data, we call it as complete data. That complete data is make our way forward to our data science analysis part. So in next demo, I will be examining the missing data using another Jupyter notebook. Will taking another taking a real world example set, like as I said, a Titanic data set. So how to visualize missing data, how to work with data to predict missing values, and one hot vectors. So let's move on to the third demonstration. Okay. In the repo, you can head over to the missing data section. There is 4.0 visualize missing data dot Jupyter notebook. So it will be displaying the demo for the Titanic dataset, find and visualize missing data. So as I explained in the earlier demonstration, if you want to import a data set to your script file, you need to use pd.read CSV part. So it will be importing the Titanic dataset. So there are 892 rows of data, which is a large data set. So if I print the head of my dataset, it will be printing first 5 rows of my dataset. How many? There are a few columns: passenger ID, survived, P-class, name, age, and barge ticket, free cabin, and embark. So it's look confusing. So I'll be explaining a little more about the dataset, what we are going to do and what we are going to predict. So so recalling our scenario, we have obtained a list of passengers on Titanic failed maiden voyage, and we like to predict and find out which kind of things predicted whether the passenger would survive. It means if it is a lady or a female person, how percentage of that person is survived in Titanic dataset. So if it is a man or if it is a child man, which percentage is that in how percentage that person is survived in Titanic. So for our first task, we will be performing here to check whether our dataset has any missing information. So at first, let's see what is the shape of our dataset. So there are 891 dataset which has 12 attributes. In order to find missing data, as I said in the Python basics part, you can use isNull one. Okay. Dataset is not defined. Okay, let's see. Okay. So in here, it will be output a descriptive analysis of our data set and say in the age column there are 177 empty cells, and in the cabin there are 687 missing values, empty cells, and in embark column there are 2 values which are missing. So in such incidences, if I ask you a question like this, if we get a data set like this, are we continue with cabin attribute or not? it is a safe bet to go with cabin attribute to our further analysis, or get rid of cabin attribute from our dataset and go ahead with other attributes. What is the safe bet? Yeah, obviously we need to get rid of those data columns. I think there are 891 data points in our data set, but from 891 data points, 687 points are missing. So what is the purpose of considering cabin attribute in our data set? So we should avoid that attribute and continue to other places of our application. So that is the point we should need to grab when we are analyzing missing values in data science. So as I visualize in here, in cabin data column, only few of the data are present and a lot of data are missing. Also in age and also in inbar. Other attributes are fine, I think, as per the output in here. So we can visualize in a matrix form what are the missing data in our data set. So after that, we can we need to avoid those missing data. So in order to avoid those data terms, we should only consider only the passenger ID, name, survivor, and age from our data set. So other data attributes we are not considering the rest of our application. So if we in order to let's see, okay, number of passengers missing, age and cabin information is 158. That what we discussed earlier. So import graphing. Let's see, graphing. Import matplotlib rather than importing graphing. I think there is a small mistake on my code. Let's see. Let's come back to this code later, but I will be moving forward with the time consumes. So after that, we need to consider about missing values, and also we need to consider about zero values. So in order to consider about zero values, so missing as zero, another issue that as I said in this markdown part, another issue to watch for this is some datasets may have missing values appearing as zero, not just missing values, not just null values, as missing value, zero values. While the Titanic dataset does not have this problem, we can moving forward. So okay, handling the missing data. So we have identified two type of missing data. One is null values and one is zero values, zero missing data. So we need to delete those missing data, but there are more options. So that is only one option, delete the missing rows, and there are some other options like replacing the empty values with mean and median for that data. It means that, so assume that you are the data collector of the Titanic dataset, but in terms of some aspects, you can guess what are the values of that term in that attribute. So in such incidences, you can input some rough value. You know that is an error. You know it is an error in your part, but you can guess that value may be a correct value for that data attribute. So in such incidences, we are replacing the original value with your value and moving forward. but we know that it is not 100% correct. So another one is adding a new category as unknown data category. So that is all about you should know about the missing data values. So if you have any questions in this part about null values and 0 missing values, you can ping me at the end of the session. So let's move forward. Okay, finally we are coming to our machine learning model. So throughout this demos, we know about what are the important libraries we should know before we are moving to data science. So, and after we getting one data set, so what are the things we should consider before we are creating our ML model? So one thing is the missing values. So after doing all of these things, so we have a data set in our hand. So after that, we need to consider so how we are going to predict whether whether a passenger going to die, going to survive or not in terms of which attribute. Likewise, so that is the question we are going to answer using data science. So in all this way, we are making our way to answer that question. So the model is the core component of machine learning. So that can be a traditional machine learning model or a traditional one, also new machine learning model. What is a traditional model? So if you think about like this, in an example like this, sometimes you might see in Sri Lanka Air Forces and Sri Lanka Navy, they are in their training session, they are training their soldiers not going to the battlefield using a simulators. It is really using pilots building using AR simulators and also in driving tests as well. So those models are implemented using physics and engineering, using knowledge of physics and engineering. So those are not machine learning models. They are exactly copying the real world model and build a computational model. So those models are traditional models. Those models are not evolving with time. They are really static, and if we simulate today, the same model will be displayed in tomorrow. But ML models, they are evolving. So evolution will be shaped by data. As long as your data is correct and valid and really important to your scenario, your model is really accurate. That's why the data is really important in machine learning and also data science, in terms of data science and machine learning. It learns from experience. So as I display in the slide, when we have a good portion of data, we can create a better model. After creating the model, we can estimate how we have to estimate how we are going to answer the question, like Titanic dataset, how in which terms of passenger is going to survive. So after we doing estimation, we need to continuously operate how to improve its performance and adding new parameters likewise. So that is the whole operation of data science when we are building an ML model. So I will taking a simple example. Will be a really simple example. So we are going to predict the dog boot size from the harness side of a dog. So that is the high level idea of our model. So the function is the model we are going to predict. The model is the function. So how we going to predict the dog boot size from the harness side? The answer will be given by the model. So models are often a simple code. It contains a logic and parameters. So parameters are considering about how many factors are depending on predicting the dog boot size depending on the harness size. So model contains logic and parameters. So selecting a model is really challenging. So whether we are going with regression, whether we are going with a classification, we are going with decision trees, likewise, so selecting a model is really challenging because many model types from simple to complex, there are neural networks are available right now. So the model, simple models from throughout all these models, the simple models are really reliable and really easy to use, where complex problems perform really impressive in fields leap forward. So you know that the application like image processing and facial recognition. So those models can't be implemented through classical ML models. We need neural networks. So, but simple questions like this, we can use any model, even a simple model or a complex model. So training enables discovering the parameters and answer to our question whether how we are going to predict the dog boot size using the harness size. So that is the basic idea of an ML model. So first we have to identify the problem. So what are the parameters and what is the logic and what is the model we are going to select in order to answer that question. Okay, let's see how we can create our first ML model using all of the knowledge we are getting through this time up to now. So let's move on to the fifth demonstration in the repository that script is including in data for machine learning, and inside it train your first ML model. So as I said, there are some data about data on boot size, and there are some data on harness size. So we are going to predict if we input the harness size, it will be predict what boot size it need to wear by the dog. So that is the high level idea. So let's execute this term. So it will be displaying all of the data we have, boot size and harness size. Okay. After that, let's see. Okay, so in this code snippet, I'm going to estimate, as I said in this, we want to use harness size to estimate boot size. That means harness size is the output and the boot size is the input. Output, harness size is the input. So selecting a model, the first thing we must do is selecting a model, as I said earlier. So let's see, we are using a simple model called OLS. So that is a straight line. Usually we can set like a trend line. It is a simple regression problem. So after training the model, we can see what is the slope and what is the intercept. So you know, in a simple linear trend line, there is an intercept, and also there is a slope. Also we can say like gradient. So after getting the slope and intercept, we can predict any of the data point we are getting by a new data point, and we can predict what is the y value if we are getting a new x value. So let's see, why am I getting error in graph? Okay, but I think there is a small error with the graphing package in my VS Code. So I will be examining the code and you after that let's see what is the problem. So in this code snippet, it will be displaying the scatter diagram. What are the x point and the y points, and then it will be drawing the trend line, and we can predict the new values in terms of our trained model. So based on that fact, we can approximate. So by giving a new harness size like 52.5, and we can approximate what is our output data. It will be predicting as 36.48. So if we input the harness size as 52.5, it will be output 36.48 boot size for that dog. So that is the high level idea of the ML model. So I think I can show you some visualizations as well. So let's see. Okay. Now this will be a improved version of the same model. So the dog boot harness datasets, I have collected 51 data points. So let's see the same data. First we are importing the data, and then we predicting the input value and the output values, and then we are taking it as a table. And okay, in this code snippet, we are going to predict if it is a small, what is the threshold for a small harness size, what is the threshold for a large harness size, likewise. So then we are going to predict some of the values based on our model, and then we are going to predict from a scatter plot. Okay, it will be training our model. Usually when the training phase, when we are building the model, it will be taking some time, because it will be taking our training data set, and it will be taking our input data set and output data parameters, and it will be going to predict and train. So what are the characteristics you should know about learning phase by the model. Okay. Looks like it will be taking more time. Okay, I think I get. Okay, so this is the scatter plot of our data set, harness size and the boot size. So let's see. Okay. Okay, I think there is a small error from we are getting the trend line, but I think this will be more than enough to explain what will be happening here. So it will be draw a trend line through these data points. It will be draw a best fitted line. So after drawing that trend line, it can predict if we are going, if the model gets a new value, he can predict what is the boot size irrespective of a certain harness size. So that is the core idea behind of our machine learning model, which is a really simple model, which is a regression case. So there are far more than complex problems like classification, decision trees, and self-organization maps, so on and so forth. So this is a really simple problem. So I hope you have understand what we are going to do and how we are going to predict, and we are going to tackle this problem using data science mechanisms. So about a little summary of our ML model. The goal of machine learning is to find patterns in data and use to make estimation. So machine learning differs from normal software development as we use in special code rather than our own institution. So in normal software production, the code will be improved day by day. It is obvious, but the data and the accuracy will not be depend on the data we are using. So to improve how well the software works, we need a good data sets. So the learning process conceptually will be different from a normal software. There are 4 components which are depending on it. First one is the data. We are first discuss about data, and then we are discuss about model. So objective is what we are trying to achieve. So in our last example, we are going to predict the dot boot size. So what is the optimizer? We are going to draw a best optimal line, which is our trend line, which is the additional code that changes the model depending on its performance. So by adding new data, by feeding new data, it will be performing more and more better to our scenario. So data can be thought of as features as label. Features corresponding to potential of model inputs, while label corresponding to model outputs. So decide model output depending on the inputs. So the NumPy and the pandas and matplotlib help us to display powerful tools to explore datasets in Python. So as we train model, we can we can save those models in our GitHub. So as a save code, but also in next session, Thathsarana will be guided you how we can integrate Microsoft Azure to deploy our models using what are the features Microsoft Azure offers us to manage our models in terms of cloud computing. So that's about it. Thank you all. I know it is a bit of a technical jargons, and here and there I'll be heading some of the errors, but in overall terms, I want to show you what are the aspects we need to know about data, how we import, what is the role data is playing in data science, and what are the things we should know when we are creating a ML model. So over to you, Thathsarana, to explain about Microsoft Azure.
Thank you very much, Sahan and Anjana, for the great content and the hands-on experience that you've given, and I also learned a lot. So yeah, so let's talk about the data science with Azure. So I hope you can see my slides, right?
We can see.
Okay, thank you, Anjana. So yeah, so let's talk about data science with Azure. So Azure provides pre-configured virtual machines in the cloud for data science and AI development. So that is called Azure Data Science Virtual Machine. So what is this Azure Data Science Virtual Machine? The Data Science Virtual Machine is basically a customized VM image, which is provided by the Azure on their cloud platform, especially for doing data sciences. So it has many popular data science tools and softwares which are pre-installed and pre-configured to jumpstart the building, intelligent applications for the advanced analytics that we experience in data science. So these data science virtual machines are available in both Windows and Linux flavor, and which comes with a variety of many popular tools, as you can see in the image. So you can see there are it covers almost all the stages in data science life cycle of the tools that are involved in each and every phases in the life cycle. Then you might be wondering why this is just a virtual machine image. Like we can create our own VM image and then install the necessary tools and softwares. Then you can use it. So you might be thinking that, but you will figure out why this data science virtual machine is different and why this is important when we talk about what we get from this virtual machine. So let's talk about it. So we'll be basically getting the analytics desktop in the cloud, right? The data science is more about the analytics. So with this fully cloud environment, this provides a consistent setup across the team and basically promotes the sharing and collaboration nearly with zero setup. What I mean by the zero setup is like that when you are doing in your personal machine or when you are doing in your own virtual machine, so you might have to create your virtual machine, and then you can install the necessary tools and softwares, and then you have to configure those things and make sure that they are compatible to each other, and it takes a lot of time, right? So, but in here, you don't need to do those things because Azure do it for you. You just need to create a VM instance, and then all the things are comes with that virtual image. And when it comes to collaboration and sharing, this is very beneficial in a working from home environment like we are experiencing these days right now. So think of a scenario where you have to work in a physical machine, and sort of a data science thing, and you are doing something that involves the team collaboration, right? So that would be hard since you all are working from your own homes, and you might have to share your screens, and they might not be able to access your machine like in very simple way. But with this cloud environment, with the desktop which is provided in the cloud, you will be experiencing those things in a very easy manner, right? So then the data science training and education. So the enterprise trainers and the educators who teach data sciences basically provides a virtual machine image because they wanted to make sure that the students have a consistent setup and the samples and the models that work predictably for the tutorials or for the sessions that they are conducting. So these data science virtual machines create an on-demand environment with a consistent setup that eases the support and intercompatibility challenges that the experience when we are working with team or when we are working in a class or learning something like that. So these cases where these environments need to be built frequently, like it's not like that you are working in a stable environment when you are learning or when you are doing a training for the data science. You'll need to create more and more instances and very frequently. So if you do it in a manual way, so it takes a lot of time, which consumes so many times in your training session time or maybe your class time or something like that. So this is very beneficial for the shorter training classes, but it benefits very substantial, right? So then the on-demand elastic capacity. This is something that we experience with the cloud computing, right? So this provides the ability to run analytics in all hardware, Azure hardware configurations with vertical and horizontal scaling. What scaling is, right? So the most important thing is that you only pay for what you use and when you use. Like think of a scenario where you need a very high, you have a very high performance task, which runs only once a year, right? So if you are using a physical machine, you are purchasing that particular hardware to run that particular job, which occurs only once a year, right? For the rest of the year, that hardware would be idle. So that would be a waste of money. But with this cloud, you will not be experiencing that kind of a scenario because you only pay for what you use and when you use. So when you don't use that particular hardware, you will not be paid or you will not be get billed, right? So then we have the deep learning with GPUs. Like in data science virtual machines, your training models can use deep learning algorithms on hardware that is based on the graphic processing unit, like the GPUs. By taking advantages of these and the VM scaling capabilities in the Azure platform which is provided, these data science virtual machines help you to use a GPU based hardware in the cloud, based on your needs, right? So you can switch to a GPU-based VM when you are training large models, or when you need a high-speed computation power while keeping the same OS in the disk. And you can choose any N-type series of GPUs-enabled virtual machines. But if you are using a free account or a student account, you will not be eligible for the using these premium features. But anyway, so these features are included. So, and the other thing is the examples and templates to get started. So this is very beneficial for a novice and beginners because this provides, the templates, examples, sample notebooks, which are built and tested by the Microsoft itself. So it enables for easy onboarding in various tools and capabilities such as, the neural networks when you're using the PyTorch, TensorFlow, and those kind of things, and also the data wrangling of R, Python, Julia, and SQL Server kind of things. So the last one is the integrate with the Azure machine learning. So we'll be talking about the Azure machine learning in a couple of minutes. So just for your information, so you can you'll get the Azure machine learning SDK, software development kit, and also the command line interface pre-installed when you get the data science virtual machine. So you can just use it to submit your distributed training jobs to the scalable Azure machine learning computing clusters to track experiments and deploy models and build the repeatable workflows with Azure machine learning pipelines. In addition to that, these Azure data science virtual machines also can be used as a compute target for training runs and Azure machine learning pipelines. So then let's move forward. So this is the end-to-end data science workflow with regards to the data science virtual machines, where you will be experiencing an input data from the data stores, and then you will get the output data, which is in a distributed way. Like you can use the Apache Spark or Azure Machine Learning or even Power BI and SQL servers and other Python extensions as well. So the other thing that I've already talked about this. So the enterprise grade machine learning service for the end-to-end ML lifecycle or the machine learning lifecycle. Like, so the first question you might get is, what is this Azure machine learning? So Azure machine learning is a cloud service for accelerating and managing machine learning lifecycles, right? So you can create a model in Azure machine learning and then or use a model that built from an open source platform like PyTorch, TensorFlow, or maybe scikit-learn or something like that. And this is mainly focusing on the individuals and the teams who are implementing the MLOps, the machine learning operations, which is very trending right now within the organizations, and to bring the machine learning models into the production and in a secure and auditable production environment. So data scientists and the ML engineers will also find the tools to accelerate and automate their day-to-day workflows. And also when it comes to the developers, they will find the tools integrating models into the applications or the services that they are working on. And when it comes to the platform teams, they can find a robust set of tools which is backed by durable Azure Resource Manager APIs, and also helps to build the advanced machine learning tools. Yeah, so so with that we'll see what the Azure machine learning provides to us for this data science. So the first thing is the data labeling. So data labeling, with this Azure machine learning, you can create, manage, monitor, and the labeling projects, and also the automate the iterative task with this machine learning assisted labeling features that is being provided. And so then coming to the data preparation, so it performs interactive data preparation with PySpark using the built-in integration with the Azure Synaptic Analysis, which is used to analyze the data. And then it comes to the collaborative notebooks, which maximize the productivity with the IntelliSense and the easy compute and kernel switchings and offline notebook editing kind of things. You can launch your notebook in Visual Studio Code for the rich development experience. As you may remember that the Sahan in the demonstration, he did the same. So including these features are including the secure debugging and supporting for the Git source control, which is provided by the VS Code itself. And then coming up to the automated machine learning, it's basically like that you can create accurate models for classification, regression, and time series forecasting rapidly. This basically use the model interpretability to understand how the model was built actually. So then it comes to one of the most interesting features, which is drag and drop machine learning. everybody likes to the GUI, like rather than the coding lines in a way, right? So this this Azure Machine Learning provides tools like Machine Learning Designer for the data transformation and model training, evaluation, and you can also create machine learning pipelines with just the mouse and drag and drop kind of things. And then also the reinforcement learning and the responsible machine learning. I'm not going to talk about these things in a much deeper manner. So, and also the experimentation. And if you talk about more services that is being provided, so it also uses a central registry to store and track data models and the metadata. So it can automatically capture the lineage and governance data with the audit file. And this also provide the integration with Git and GitHub, where you can track the work, and also you can integrate with the GitHub Actions to support the implement the ML workflows, ML pipelines. And the other thing, it provides a managed endpoint where you can deploy a model and get the output with a web service endpoint or in a backend endpoint. And the other thing is the auto scaling compute, where you can, based on the requirement, you can use the managed computing to distribute, share the CPU and GPU clusters across a workspace and automatically scale to meet your machine learning requirements. And the deep integration with the Azure services, where you can integrate it with the Azure Synaptic Analysis, Cognitive Search, Data Factory, Data Lake, Arc, Security Center, and many other services that have been provided by Azure. And also this can, you can work in hybrid cloud environment where you can, run machine learning on the existing Kubernetes clusters in your on-premises servers, and also in your cloud in the Azure VM. And it also provides the enterprise grade quality, security, and also the cost management features as well. So moving on to the end-to-end machine learning life cycle, you can experience all these phases, and you can manage all these phases in your ML life cycle with this Azure machine learning, with the integration of Azure DevOps as well, right? So with that, I would like to move on to how you can learn data science with Microsoft Learn. Especially Microsoft Learn is, or you might know or not aware, like it's an extension to Microsoft documentation where we can, follow some tutorials, and it's a very immense content. It consists of different paths where you can choose your path, like path in the sense of like a occupation, like we have the paths for the developer, administrator, data scientist, data engineer, AI engineer, machine learning engineer. So you can choose your own paths and follow the tutorials, follow the course modules that have been provided. So it's a very good option, very good chance for you to learn data science with Microsoft Learn. And but don't put a full stop there, because Microsoft provides you an opportunity not just to learn, but also to validate your skills, and they have introduced many certifications with regards to the data science. I've brought here the the most important certifications, where the first one is a Microsoft Certified Azure Data Fundamentals, which is for the beginners who are new to the data science with Azure. And then you have the Microsoft Certified Azure Data Scientist Associate, which is a bit more advanced, but but it's not a prerequisite for you to do the Azure Data Fundamentals, but you can directly do the Azure Data Scientist Associate. So by taking the exam, designing and implementing data science solution on Azure, so which is, as I remember, it's the DP100, the exam code. And if you are beginner, if you are novice to Azure, you can take the Azure fundamentals exams as well, other than these two exams, to get to know about Azure and how the cloud computing works and kind of things. So with that, I would like to conclude the segment 3